The most important question we can ask is this: are we alone in the universe? This profound thought, spoken by Carl Sagan, continues to shape the minds of astronomers and space enthusiasts across the globe. Sagan wasn't just a dreamer, he was a visionary who deeply understood how monumental it would be to find even the tiniest hint of extraterrestrial life. For decades, scientists have looked to the stars, hoping to find signs of life beyond Earth. That hope is now closer than ever to becoming reality. Thanks to the James Webb Space Telescope, JWST, we are peering deeper into the cosmos with unprecedented clarity. JWST is like a time machine and microscope rolled into one, revealing details about distant galaxies, stars, and planets that were previously unimaginable. Among the thousands of cosmic wonders JWST has uncovered, one exoplanet stands out: K2-12B. This mysterious world lies in the constellation Leo, more than 120 light-years from Earth. It orbits a red dwarf star called K2-18, a much smaller and cooler version of our Sun. Even though its parent star is dim, K2-18b exists in the so-called habitable zone. That means it's located at just the right distance from its star where liquid water might exist. And where there's water, there could be life. K2-18b isn't just a boring rocky world. It's a sub-Neptune, larger than Earth but smaller than Neptune. Even more fascinating is that it belongs to a special group of planets known as Hycean planets. This term was coined by astrophysicist Niku Matsudan, who describes Hycean planets as having hydrogen-rich atmospheres and global oceans hidden beneath thick clouds. The JWST has already discovered water vapor in K2-18b's atmosphere. But what really stunned scientists was the possible detection of a molecule called dimethyl sulfide, DMS. On Earth, DMS is produced almost entirely by living organisms, especially tiny marine microbes. That makes it a biosignature, a chemical clue that could point to life. To detect these clues, scientists used a method called transit spectroscopy. This technique involves studying starlight as it filters through a planet's atmosphere. By analyzing how the light breaks into different wavelengths, researchers can identify specific gases. In K2-18b's case, the light revealed methane, carbon dioxide, water vapor, and possibly DMS. If confirmed, this would be a groundbreaking find. It suggests that something may be alive in the depths of that alien ocean. Dr. Niku Matsudan, who led the research team, said, "This is the first time we've seen such a strong indicator of potential life in a planet's atmosphere so far from our solar system." He emphasized that while these results are not confirmation of life, they are very promising. What excites scientists even more is the idea that K2-18b could have a liquid ocean beneath its hydrogen-rich atmosphere. If that ocean is warm and contains the right chemicals, it could support microbial life, much like the early life forms on Earth. Dr. Sarah Seeger, a planetary scientist from MIT, believes we are on the verge of discovery. For the first time in human history, we are close to answering the question of whether we are alone, she said. Seeger has spent her career developing techniques to detect signs of life in distant atmospheres. This shifts our understanding of what a habitable planet looks like. We once thought life could only exist on Earth-like planets, rocky worlds with breathable atmospheres. But now we know that planets with thick hydrogen atmospheres, deep oceans, and extreme environments might also be ideal homes for life. Even in our own solar system, moons like Europa, orbiting Jupiter, and Enceladus, orbiting Saturn, have subsurface oceans. NASA's Cassini spacecraft detected organic molecules in the geysers erupting from Enceladus, proof that we don't need sunlight or surface warmth for life to exist. The JWST is doing more than searching for life. It's also studying how planets and galaxies form and evolve. It's giving us a look at the chemical makeup of the early universe and helping us understand the origins of planetary systems. This is why many scientists are calling it the golden age of exoplanet science. Every new discovery brings us one step closer to finding life elsewhere. The search for alien life is no longer just a dream, it's a real scientific mission. Another exciting target for JWST is TRAPPIST-1e, a planet just 40 light-years away. It's part of a system with 7 rocky planets, several of which orbit in the habitable zone. JWST has started observing them for the same chemical signatures seen in K2-12B. Then there's LHS 1140b, a rocky planet around 49 light-years from Earth. It too is in the habitable zone of a red dwarf star. It might have an ocean and a thick atmosphere, making it a prime candidate for future study. Scientists are planning follow-up studies on K2-12B to confirm the presence of DMs and look for other biosignatures like ozone, ammonia, and nitrogen compounds. If several life-related chemicals are found together, the case for life becomes much stronger. Upcoming missions like the European Space Agency's Aerial Telescope and NASA's Habitable Worlds Observatory will continue this search. Aerial will analyze hundreds of exoplanet atmospheres, while the Habitable Worlds Observatory aims to study Earth-like planets around nearby stars in greater detail. The universe contains over 100 billion galaxies, each filled with billions of stars. If just a fraction of those stars have planets in habitable zones, we could be looking at millions of possible homes for life. Dr. Jill Tarter, one of the pioneers of the SETI program, has long said that the absence of evidence is not evidence of absence. She believes that we are now building the tools to finally detect the evidence we've been seeking. Every discovery reshapes our view of life and the cosmos. Finding life, even microbial life, would prove that Earth is not unique. It would suggest that life is common, possibly arising whenever and wherever conditions are right. The impact would be profound. Philosophers, theologians, and scientists would all have to rethink humanity's place in the universe. We'd no longer be the only known life form, we'd be part of a cosmic community. For young people today, these discoveries are not just inspiring, they are career-changing. Students who watch JWST's work today could become tomorrow's planet hunters, space explorers, or astrobiologists. The next generation might be the first to send probes to exoplanets or walk on the surface of a moon like Europa. We're training our telescopes not just on stars, but on entire worlds, each with their own story. What if one of those stories includes life? What if right now, deep in the oceans of K2-12B, simple organisms are thriving? If we confirm this, it would be one of the greatest discoveries in history. Dr. Thomas Verbuchen, NASA's former science chief, said, "This is the closest we've ever come to finding life beyond Earth. And we're just getting started." His optimism is echoed by many in the scientific community. K2-12B is just the beginning. There are thousands more exoplanets to study, each with its own potential to surprise us. As technology improves, we may find not just microbes, but even signals from intelligent civilizations. The idea of discovering intelligent life may sound like science fiction, but some researchers are seriously working on detecting technosignatures, like artificial light, radio signals, or pollutants that indicate industrial activity. If we find even one of these signals, the implications would be unimaginable. It would mean that we are not alone, and that somewhere out there, another form of intelligence is watching the stars just like we are. Every telescope, every mission, Every discovery brings us closer to answering the age-old question that Carl Sagan so elegantly posed. And each answer leads to even more questions about our universe, our origins, and our destiny. As we continue exploring the stars, we must remain curious, open-minded, and hopeful. The universe is vast, mysterious, and filled with potential. The adventure has only just begun. Subscribe to our channel and thanks for watching.